और इसमें ना जो जो एएस की एनालिटिकल केमिस्ट्री है ना, वो सारा ही हम कवर कर लेते हैं कि उसके अंदर देयर इज अ थिंग कॉल्ड मास स्पेक्ट्रोस्कोपी। ठीक है, अब पता नहीं क्लास में मेरे ख्याल से किया था, छोटा सा टॉपिक है, बहुत छोटा सा टॉपिक है। उसके अंदर है कि हाउ डू यू फिगर आउट कि an atom has how many carbon atoms etc. How do you figure out this structure, क्योंकि you can't see this structure, तो how do you figure out कि भाई यहाँ पे ना there is a C double bond O और यहाँ पे ना CH है, यहाँ पे CO है। how do you figure out the structure of a molecule? ठीक है, तो उसके अंदर था कि मास स्पेक्ट्रोस्कोपी जो है ना, वो आपको ना ये सारी चीजें, ये सारी इंफॉर्मेशन जो है ना, इट प्रोवाइड्स दैट इंफॉर्मेशन के it gives you the number of carbon atoms, it gives you the molecular mass, it sometimes gives you information about the structure, and it gives you the number of Cl and Br atoms. ठीक है, topic simple है, मतलब concept was complicated but the topic is itself very simple कि what you do is कि when you do mass spectroscopy तो आप एक मॉलिक्यूल को पकड़ते हो। ठीक है, let's say आपका ना CH3Cl का मॉलिक्यूल है। ठीक है, दिस वन ओवर हियर। अच्छा, इस मॉलिक्यूल को ना यू बम्बार्डेड विद इलेक्ट्रॉन्स, तो ये जो आपका मॉलिक्यूल है ना, इट टर्न्स इनटू एन आयन व्हिच इज नोन एज द मॉलिक्यूलर आयन। ठीक है, दैट इज CH3Cl+1, क्योंकि CH3Cl और +1 चार्ज आ जाता है उसके ऊपर। या फिर what happens is that the electron beam breaks the molecule into smaller pieces. तो यही जो आपका मॉलिक्यूल है ना, it shatters into tinier and smaller pieces. तो हो सकता है कि उसके अंदर से ना you might get any type of piece कि ये CH2 जो है ना, this has broken away. So that is one piece that could be formed. या फिर what could happen is that this thing CH2Cl+1 ion can be formed. That piece might break away. So small tiny pieces can be formed. CH2Cl+1 fragment, इसको fragment कहते हैं। तो you have a heavy molecular ion and you have these tiny pieces that are formed in this ionization chamber. ये clear है बात? आयशा clear है? Aruba, Javeria, Noor, is this clear? Clear है?
Sir, could you explain it again? I don't know.
अच्छा, नहीं, what I told you was that you take a molecule, you bombard it with electrons, with lots of electrons, and the electrons knock out. I mean, this is the molecule, right? So the molecule can either turn into an ion, it might lose an electron. So I took a CH3Cl molecule, right? So when the electrons come in, they might knock out a few other electrons, right? So, I mean, this entire thing could turn into an ion. I mean, that is one possibility. Or what could happen is that it could break into tinier pieces. Like it could break into a CH3. I mean, you're smashing things, right? Think of you like you pick something and you smash it against something, right? So it's going to break into tiny pieces. Is that clear? The idea clear? Is that clear?
Yes.
And the tiny pieces could be any piece. It could be a CH2+1 ion. I mean, the Cl+1 can break away. This thing could, I mean, this piece could be formed. That's CH2. So the point is that lots of tiny fragments are formed. Okay, lots of them. But the heaviest one, the biggest one is your molecular ion. Is that clear? So in the ionization chamber, you'll have this big ion and lots of small tiny pieces, and all of them will have a +1 charge. Basically, they can have any charge, but you're focusing on +1 ions. The beam is made out of +1 ions. I mean, it could be a -1 ion, it could be a -2 ion. Any number of electrons electrons can be gained, any number of electrons can be lost, but we focus on +1 ions. So we somehow filter off all the other ions and we create a beam of +1 ions. And all these ions, they travel in a beam and they pass through a magnetic field. And in the magnetic field, remember that deflection is inversely proportional to mass. Charged particles, when they travel through a magnetic field, they're going to get deflected. Okay, that's basic physics, left-hand rule. So when they get deflected, the heavy ones are going to be deflected less because it's more difficult to deflect heavy ones. The lighter particles would be deflected more. So what happens is, and deflection is inversely proportional to mass. So what you do is, by looking at the deflection, you can estimate the mass of the particle. I mean, that is how you measure the mass of atoms. What you do is, if there is less deflection, it's going to be a heavier mass. It's going to be a bigger mass. So you calibrate the instrument so that you can figure out the mass. But anyways, the least deflected are the molecular ions. They are the heaviest ones. So it would be very hard to deflect them. Relatively speaking, your fragments are like really tiny, so they get deflected more. The tinier the fragment, the more its deflection is going to be. Now we are interested in the molecular ion, which is CH3Cl+1. Now the molecular ion is going to have two different masses. It can either have a Cl which has a probability, Cl, I mean, there are two types of Cls. One is 35, the other one is 37. Normally isotopes are very rare, but in the case of chlorine, isotopes are kind of abundant. So Cl is 35, Cl is 37. 75% chances that you get Cl35, 25% chances that you're going to get Cl30s. Out of 100 particles, on average, there would be 75 Cl35s and 25 Cl37s. So 3 by 4 and 1 by 4, that's the probability. So your molecular ion is going to have two different masses. They would be basically two different molecular ions. One will have a mass of 52, one will have a mass of 50. One would be slightly heavier, one would be slightly lighter. Why? Because one will have Cl35, the other one will have Cl37. Carbon is 12, hydrogen is 1. The other isotopes are rare, so we're not going to talk about them. But there's going to be a variation in the mass. Why? Because of chlorine. This is known as the molecular ion peak, M peak, the lighter one. There's a difference of 2, so that one is known as the M+2 peak. This one will have a 3 by 4 probability. This one will have 1 by. So for when you detect 4 particles, 3 of them would be on average having a mass of 50, and one of them on average will have a mass of 52. So your mass spectrum would kind of look like this. That you'll get smaller masses, you'll get lots of different particles, but the heavier ones, the molecular ion, there would be two different peaks. There's going to be a detection at 50 and there's going to be a detection at 52. At 50, the chances of detecting 50 is going to be higher because the chances of getting 35, it's got a higher probability, 3 times higher compared to the chance of getting 37. So 50 would be 3 times more. I mean, so if you detect 300 particles of 50, there would be 100 particles having a mass of 52. So is this clear? Okay, how chlorine?
Yes, sir.
ठीक है, बाकी और clear है? Aisha, clear? Aruba, Iman, is this clear?
Yes, sir.
Okay, anyways, the question would be very simple. If you're given a mass spectrum and you have an M peak and you have an M+2 peak, and if the ratio is 3:1, that clearly indicates that there is 1 Cl present. Okay, that's it. And similarly, you can have 2 Cls. If you do the same thing with a molecule that has 2 chlorines. So here's another molecule, and it could be any molecule if it has 2 chlorines. So it's going to be a heavy molecular ion and smaller fragments, right? They pass through the magnetic field. The smaller fragments are going to be deflected more. The heavier one would be the molecular ion. ठीक है, that would be the heaviest. And if you have two CLs, they're going to be three different masses of this molecular ion. Why? Because either it's going to be a lighter version of it, okay, both CLs are 35, have a mass of 35. So आपका बन जाता है 112. Like if you add up them, carbon 12, 12, 12, and that's 42 plus 2 CLs. So then there's going to be a slightly heavier version of this molecular ion. So उसकी deflection थोड़ी सी कम होगी because it's slightly heavier. So उसमें one of them is 35, the other one is 37. तो उसकी mass होगी 114. So difference is 2, so that is m plus 2. And then there's going to be a heavier one, which is both of them are 37. Both CLs in this are 37. So that is 116. तो आपके पास ना, there's not going to be one version of the molecular ion. There would be three different versions of the molecular ions. In the mass spectrum, there would be three different detections: one at m, one at m plus 2, one at m plus 4. Well, 112, 114, and 116. And the probability would be, okay, what was the probability of getting 35? That was 3 by 4. What's the probability of getting the other one as 3 by 35? That's 3 by 4. So it's 3 by 4 into 3 by 4, that gives you 9 by 16. What's the probability of getting CL37? That's 1 by 4. And the other one is also 37, that's 1 by 4. So that's 1 by 4 into 1 by 4, that's 1 by 16. And then you have, what's the probability of getting, one of them is 37. So, and one of them is 35. So it's either the first one is 35 and the second one is 37, or the first one is 37 and the second one is 35. And that gives you 6 by 16. So basically at the end of the day, 112 आने के chances ज़्यादा है, 9 out of 16, more than 50%. Like every time you detect this thing, it's probably going to be this one. इसके chances आने के बहुत कम है, 1 by 16, that's either less than 10%. Probably around 6-7%. तो इसकी probability बहुत कम है. तो आपकी जो detections हो रही होंगी ना mass spectrum में, इस mass में ना detection सबसे ज़्यादा होगी, इस पे detection m plus 4 पे detection would be very less. And in what ratio? It would be 9 ratio 6 ratio 1. और ये आपके ना छोटे-छोटे fragments, कम masses के ऊपर ना छोटे-छोटे fragments detect हो रहे हैं randomly. So whenever you do mass spectrum and you see, so whenever you do mass spectrum and you see an m plus 2 and m plus 4 peak in the ratio 9 ratio 6 ratio 1, तो वो clearly indicate करता है that the molecule has 2 chlorines. ठीक है, इस आप 3 chlorines भी कर सकते हो, 4 भी कर सकते हो. So the basic idea is you can figure out the number of chlorines by looking at the m peaks. ठीक है, और उनके ratio को figure out कर लो. You will immediately know. I mean, you will not be able to see the molecule. All you'll be able to see is this thing. And when you see 9 ratio 6 ratio 1, that indicates that there is 2 chlorines. Or simultaneously, when you see an m peak and an m plus 2 peak and the ratio is 3 ratio 1, then that clearly indicates that there is 1 Cl present. ठीक है, ये दोनों बातें clear है? यानी that's
Yes, sir.
That's the summary. ठीक है? If a molecule has 1 Cl, or if a molecule has 2 Cls. अच्छा, फिर एक और atom है, उसके isotopes बहुत
Sir,
important.
will we be getting questions about 3 chlorines or maybe 4 chlorines?
नहीं, 3 chlorines का तो नहीं आएगा, और इसको वैसे क्योंकि सिलेबस चेंज हुआ, चेक भी कर लेते हैं. पर वो तो फिर उसके लिए तो probabilities calculate करना, वो तो फिर probability का question बन जाएगा, वो तो math का question बन जाएगा. They'll probably limit it to 2 Cls. ठीक है, तो इसका इसमें है ये तो चलो ठीक है, ये भी करना है. बस एक सेकेंड. 5 और अभी उन्होंने m plus 4 भी निकाल दिया एक्चुअली. पहले गए तो फिर देख लो. बस ठीक है, 3 CLs वाला तो आउट ऑफ टोटली आउट ऑफ द क्वेश्चन है, बल्कि ये 2 CLs वाला भी आउट ऑफ द क्वेश्चन है अब, क्योंकि नया सिलेबस उसमें बस लिमिट किया हुआ है M+2 तक। तो आई थिंक ये रिडंडेंट है। पास पेपर के सारे क्वेश्चंस M+4 तक होंगे, इसको भी मेरे ख्याल से ना, जस्ट टू बी ऑन द सेफ साइड, कोई इतनी लंबी इतना मुश्किल काम तो नहीं है, बस वो 2 CLs तक अभी याद कर लो, क्योंकि पिछले साल तक 2 CLs तक था, ठीक है।
And sir,
यस
one more thing. पेज नंबर 22 देख लें सिलेबस का, 8.3 होमोजेनस एंड हेट्रोजेनस कैटलिस्ट। सर ये
हाँ
चीज है कोर्स में या नहीं है?
नहीं है, वो भी 2 लाइनें बस,
ये हमने की हुई है।
नहीं किया हमने, रिएक्शन काइनेटिक्स नहीं किया, वो हो जाएगा 10 मिनट में हो जाएगा, ये तो A2 का है।
ओ ओके ओके, A2 का है सर, AS का ही है?
नहीं, मेन टॉपिक जो है ना सारा वो A2 के अंदर है,
ओके
जो AS किधर गया, रिएक्शन ये ये आपका है ना, मैं वो जल्दी से बता देता हूँ, आप लोगों ने क्या करना है, बाकी तो सारा वही है ना, वो कोलिजन, कंसंट्रेशन, प्रेशर, वही O लेवल्स वाला ही है, इफेक्टिव नॉन, मतलब जो O लेवल्स में नहीं पढ़ा था, ठीक है। O लेवल्स में रेट ऑफ रिएक्शन नहीं बनाते थे, वो ग्राफ से लाइन ड्रॉ कर लेते थे, ग्राफ ऊपर जा रहा है, एक्टिवेशन एनर्जी वही O लेवल्स वाली है, ठीक है, उसमें मतलब कोई नई चीज नहीं है, ये बस सिर्फ बोल्ट्जमैन डिस्ट्रीब्यूशन है, एक ग्राफ है, उसके अंदर कोई खास साइंस नहीं है। तो बोल्ट्जमैन डिस्ट्रीब्यूशन का ग्राफ करना है, वो 5 मिनट में हो जाएगा, और एक्सप्लेन द प्रेजेंस ऑफ कैटलिस्ट, वो एक्टिवेशन एनर्जी कम करता है, वो सारा ये वो जो ये भी O लेवल्स ही है, ठीक है। पाथवे डायग्राम, प्रेजेंस ऑफ एन, ये वो डायग्राम नहीं होता, वो नीचे हो जाती है कर्व, ये सारा O लेवल्स है, इसमें कोई नई चीज नहीं है। हेट्रोजेनस कहाँ पे, ये वाला ना,
यस सर,
हाँ
8.3।
हाँ, उसके अंदर बस डेफिनेशन हेट्रोजेनस वो है कि मतलब ये जो है ना, इसमें कोई भी नई चीज नहीं है, वो बस हम एक दफा वही गो थ्रू कर लेंगे। बोल्ट्जमैन डिस्ट्रीब्यूशन है जो बस करनी है, वो बस एक ग्राफ है और कुछ भी नहीं है, ठीक है। वो तो क्लियर है ना, ये रिएक्शन पाथवे डायग्राम जो O लेवल्स में नहीं करते थे, एक्सोथर्मिक, एंडोथर्मिक, और वो कैटलिस्ट डालने से वो नीचे आ जाते थे, वो क्लियर है।
जी जी।
Yes, sir.
तो ये वही है, और होमोजेनस और हेट्रोजेनस का सिर्फ मतलब ये, होमोजेनस होता है कि कैटलिस्ट की स्टेट वही होती है, हेट्रोजेनस होता है कि कैटलिस्ट की स्टेट जो होती है ना, वो रिएक्टेंट्स से डिफरेंट होती है, बस ये दोनों का मतलब है कि अगर वो, मतलब उस पे ना क्वेश्चन सिर्फ आएगा कि अल्कीन नहीं है, अल्कीन अगर वो हाइड्रोजनेशन हो रही है, निकल कैटलिस्ट है ना, निकल सॉलिड होता है ना, तो अगर डिफरेंट स्टेट होगी तो बस उसको हेट्रोजेनस कैटलिस्ट कहते हैं, और सेम स्टेट होगी तो उसको होमोजेनस कहते हैं। इसका वो भी ना, हाँ ये सारा भी ना, इसकी जो वर्किंग है ना वो A2 के अंदर है, क्लियर है। मैंने ये वो सारा ना डिसाइड द मोड ऑफ एक्शन ऑफ, ये सारा जो है ना 26.2 ये A2 है, क्लियर है। तो
ओके
तो रिएक्शन काइनेटिक्स में वैसे क्लियर कर दूं, उसके अंदर वो अगर वैसे भी गो थ्रू से बोल्ट्जमैन डिस्ट्रीब्यूशन है, और वो कुछ भी नहीं है, वो अभी इस क्लास के एंड में कर लेंगे, ठीक है। तो ये वाला जो है ना पेज 38 वाला, ये तो A2 के अंदर है, ये पूरी डिटेल है, उसके अंदर कुछ भी नहीं है, उसके अंदर वही O लेवल्स वाला है, जिसमें वो कौन सा ग्राफ होता है, एनर्जी प्रोफाइल डायग्राम ना, मैं
Okay,
सर
sir.
ये वाला तो नहीं, खैर वो जो ये भी वही है, पर ये नहीं होता था, तो इसमें बस वो क्या होता था, कर्व नीचे आ जाती थी, दैट्स इट। ये बस हमने करना है, ये जो बोल्ट्जमैन डिस्ट्रीब्यूशन है ना, खैर ये तो उसके, ये तो प्रोबेबिलिटी के साथ लिंक्ड है, लेकिन ये मैथ है, लेकिन उसकी भी शक्ल इसी तरह होती है, उसकी टेंशन ना लो, उसमें कुछ भी नहीं है, उसमें कोई खास चीज नहीं है, वो हम गो थ्रू कर लेंगे। बस ये था लास्ट के, कहाँ पे गए हम, वो क्लियर है, रिएक्शन काइनेटिक्स क्लियर है कि वो हमारे उसमें कोई नई चीज कुछ भी नहीं है सिवाय बोल्ट्जमैन डिस्ट्रीब्यूशन के। अच्छा चलो क्विकली, और बल्कि इसमें भी ना वो भी हमने देख लिया, कि उन्होंने नए सिलेबस में ना ये M+4 निकाल दिया है। मैं इसलिए नहीं निकाल रहा क्योंकि अभी तक M+4 पिछले सारे पास पेपर्स में होते थे, तो वी गोना कीप M+4 फॉर नाउ। क्यों बेसिक रिस्क लेने की बात है कि क्या पता वो पूछ ले। अच्छा दिस वन ब्रोमीन का मैं क्विकली कर लूं कि व्हाट हैपेंस इन। अच्छा नहीं ईमान क्या क्वेश्चन है? अच्छा चलो ये ब्रोमीन का हम कर लेते हैं। नाउ ब्रोमीन इज एग्जैक्टली द सेम, ठीक है। Just remember कि bromine when you do mass spectroscopy of a bromine molecule, if it has 1 Br, तो उसमें ना in the case of bromine, both bromines have equal probability. Bromine has two isotopes, one is 79, the other one is 81. 50% chance उसके आने के, 50% is the chance of getting 81. So it's 1/2, 1/2, equal probability. So when you do the mass spectrum of a molecule that has 1 Br, now that Br could be 79. So if it is 79, it will have a mass of 94. And that Br could also be 81. If it's 81, then this thing will have a mass of 96. Both of them will have equal probability. This is known as the M peak. This is the M+2 peak. So दोनों के chances आने के equal है क्योंकि it's you could either have 79 or you could have 81. And दो bromines अब मेरे ख्याल से कोर्स में ही लेकिन कर लेते हैं. If you have two bromines in a molecule, any molecule, so its mass variation would be M+2, M+4. Okay, either both of them are 79, then one of them would be heavier by a mass of 2. Okay, one of them would be 81, or it would be heavier by a mass of 4. Both of them would be 81. So what's the chances of getting both of them as 79? That's 1/2 into 1/2. What's the chance of getting both of them as 81? That's 1/2 into 1/2. Or iski probability jo hai na wo 2/4 hai. So the relative heights would be M+2, M+4. That's 1 to 1. Okay, 1:2:1. If you detect 1,000 particles of this, 2,000 would be this, 1,000 would be this. So this is all you have to remember. Okay, if a molecule has 1 Br, it will have M+2 height, and they would have equal ratio. And if a molecule has 2 Brs, then it will have 3 different peaks, and in the ratio 1:2:1. Okay, is that clear?
Yes, sir.
And this is exactly the same as BrCl का कर लेते हैं. अच्छा ये फिर totally out. ये फिर अब since they don't mention anything in the syllabus now, you can go through this. It's the same exact thing. If a molecule has 1 Cl, 1 Br, this thing is now kind of looks totally out of syllabus now. Okay, but I'll just briefly go through this. If it has 1 Cl and 1 Br, तो Br के ये दो chances हैं. It could either be 79, it could be 81, and the Cl has 2 chances. It could either be 35, it could be 37. So if I have this molecule and it's got 1 Br and 1 Cl, so either both of them are the lighter versions, 79 and 35. What's the probability? Half for this and 3/4 for this. So that would give you 3/8. So M आने के chances जो है ना 128 जो बन रही है, that is 3/8. फिर हो सकता है कि you could have a slightly heavier one, 130, having a mass of 130. It's going to be 14. One of them is 79, the other one is slightly heavier, that's 37. Or it could be the other way around. Okay, this is 81 and the other one is 35. Actually, in this case, the probability comes out to be 4/8. And then both of them could be the heavy ones. Then you're going to get an M+4 peak. And in that case, it's going to be this probability is half and this is 1/4. That comes out to be 1/8. So relative height showing that's going to be ratio 3:4:1. So your graph would kind of look like this. Okay, so if a molecule has 1 Cl and 1 Br, so the very last thing is, अच्छा ये सारा clear है? पिछला इस पे कोई question तो नहीं है? Basic math है कि how would the mass?
No, sir.
ठीक है, कोई confusion तो नहीं है? How would the mass of a molecule change?
Sir,
And
type
yes,
of questions क्या होंगे?
क्या चीज? अच्छा
Like, how would they ask?
मैं इस पे क्या question आ सकता है? इस पे बहुत ही basic question आएगा. but I'll just open the questions. ठीक है? अच्छा, remember you're not going to find any questions in AS क्योंकि अभी ऐड किए A2 के अंदर होंगे इसके questions. ठीक है? So they would be very very basic. But exactly जो हमने पढ़ा है ना, they'll just ask that. That's it. So one example is कि अच्छा ये जैसा ना, what would be the difference in the ratio of the MM+2 peak if the pesticide contained 1 chlorine rather than 1 bromine? तो क्या आंसर होगा? 1, वो कह रहा है 1 क्लोरीन है, तो मैंने क्या बताया था, अगर 1 क्लोरीन होगा तो उसका it would have, if a
3:1.
तो MM+2 ratio would be 3:1. और अगर 1 bromine होता तो 1:1 क्योंकि both isotopes would have equal probability, right? So yeah, if a given pesticide contained 2 chlorine atoms, deduce the relative heights of the MM+2 and M+4 peak. So वो 2 chlorines, so 9:6:1, that's it. ठीक है, is that clear?
Yes, sir.
तो इस पे मतलब कोई वो नहीं आएगा कि, but बिल्कुल बेसिक्स आएगा, मतलब इसलिए ना, मतलब this topic is kind of easy. It's, you just have to remember कि ये दिया हुआ है. It had an M+2 peak of similar height to the M peak. यानी M and M+2 peak had similar heights. What does that mean? If M and,
Bromine.
so that means definitely not chlorine. वो bromine के तरह गया है. ये वाला. When do the MM+2 have similar height? When they have exactly 1 bromine. ठीक है? Clear है? और ये भी याद रखो, अब क्वेश्चन और भी सिंपल होगा क्योंकि उधर कहीं लिखा हुआ है, अब जो नया सिलेबस है ना उसके अंदर कहीं लिखा हुआ नहीं है कि दे नॉट इवन टॉकिंग अबाउट द M+4 पीक. तो अब ये वाला क्वेश्चन भी शायद ना आए, लेकिन जस्ट टू बी ऑन द सेफ साइड ये वाला भी याद रख लो, क्योंकि अभी तक इससे पहले कोई, क्योंकि नया सिलेबस है, वी डोंट नो हाउ दे, कभी कभार दे देते हैं, वी डोंट नो एग्जैक्टली हाउ दे इंटरप्रेटिंग इट, बट जस्ट टू बी ऑन द सेफ साइड ये याद ही रख लेना, जस्ट रिमेंबर 2 bromines, that's it. अच्छा, now anyways, let's move on कि वो फिर कार्बन्स के ऊपर आ जाता है. You've got, अच्छा now कार्बन का ये कि you can figure out the number of carbon atoms by looking at the mass spectrum. Carbon has isotopes but not as abundant as chlorine or bromine. 99% chance है कि carbon 12 होगा, 1.1% chance है that it would be carbon 13. So if I have a CH4 molecule and I do a mass spectrum of it, so I'll get a mass of 16 and I will also get a mass of 17 as well. Okay, there would be a particle, molecular ion. This is known as M+1 क्योंकि एक का difference है ना. So this is M+1. So why would you get 17? Because carbon could be 13, so the mass increases by 1, just 1. So या तो mass 16 आएगी या mass 17 आएगी. What's the probability of getting 12? That's 99%. ठीक है, मैंने round किया 99%. What's the probability of getting 13? That's 1%. So 99% chance you'll get this, and there's only 1% chance of getting 17. So the relative ratio of the particles detected would be 99:1. लेकिन what will happen is कि अगर number of carbon atoms increase हो ना, if I have 2 carbons in a molecule, so there's a probability that both of them would be carbon 12. That would give me the M peak, which is 30 in this case. 12 plus 12 plus 6 hydrogens, right? So probability क्या होगी इसकी? 99% for carbon 12 and 99% for the other one being carbon 12. अगर वो आप math करो ना, you get 98%. ठीक है? What's the probability of getting M+1 peak? 1% into 99%. And there would be 2 events. वो उल्टा भी हो सकता है. This one would be 12 and this one would be 13. So times 2, that is 2%. So what is happening is there's a trend that's happening. As the number of carbon atoms increase, तो जो M वाली height है ना, वो it starts to decrease. It was 99:1, now it's 98:2. If a molecule has 3 carbon atoms, फिर क्या होता है? फिर होता है कि getting 3 as carbon 12, all 3 carbon 12, what is the probability? That's 99% into 99% into 99%, that comes out to be 97%. तो m की height छोटी होती जा रही है, ठीक है, and the m plus 1 height is increasing. What if one of them is 13? That would give you m plus 1. So either it could be this one, or it could be this one, or it could be this one. So there would be 3 different events. That one of them is 13, the other 2 are 12. So 12 and 12, and one of them is 13. But there would be 3 different scenarios. There were 3% are. So the trend is okay, you can figure out the number of carbon atoms by looking at the mass spectrum by comparing the m peak to the m plus 1 peak. Ratio agar kam hota ja raha hai, that means the number of carbon atoms are increasing. And so is that idea clear?
Sir, so the ratio of the m plus 1 peak is equal to the number of carbon atoms?
हाँ, मतलब ratios आप estimate कर सकते हो ना, number of carbon atoms. Is that clear? कि अगर 99 ratio 1 है, तो it means कि it's 1 carbon atom. If it's 98 ratio 2, that means it's 2 carbon atoms. If it's 97 ratio 3, that's 3 carbon atoms. But if 4 carbon atoms पे क्या आएगा? 96% आएगा और 4% आएगा. Is that clear?
Yes.
अच्छा, the simple way is you use this formula. ठीक है, there's a formula that instead of comparing the ratio, m plus 1 height, put the m plus 1 peak over here, the m peak over here, put it in the formula, and you'll get the number of carbon atoms. Well, as an example, but इसको use कर लेते हैं ना. As an example, it's 97 ratio 3, right? Or remember, उन्होंने ratio इस तरह नहीं दिया होगा. Maybe 48.5 ratio 1.5 is the same ratio. But 97 ratio 3 is the same as 48.5 ratio 1.5. ठीक है, so it's exactly the same ratio. तो आप क्या करोगे कि instead of measuring it, what you can do is you can just put it in the formula. Formula क्या, it's you want to figure out the number of carbon atoms. So it's going to be 100 over 1.1 into, let's say, 1.5 was the m peak and 48.5 was the. तो ये उस पे करो, कैलकुलेटर पे करो, what do you get? है किसी पास क्या कैलकुलेटर पे? What do you get for this? किसी ने किया?
2.8.
ठीक है, एक से होल्ड कर दो. अच्छा, सॉरी. हाँ, क्या आंसर आया था? 2.8. So that, I mean, you round it off. That's
Yes.
3. अच्छा, that's 3 carbon atoms. ठीक है. Is the idea clear? कि मतलब ये formula you can just plug the m plus 1 m height into this and you'll get the number of carbon atoms. ठीक है, clear है?
Yes, sir.
क्योंकि मसला ये होता है कि रेशियो उन्होंने ना 98 रेशियो अगर 2 दिया होता ना, that would be easy कि you would know it's 2 carbon atoms. ठीक है, they won't give you 98 ratio 2. They'll probably give you something like 49 ratio 1 मतलब वो दिखा देता हूँ कि अभी मैंने खोला हुआ भी था. So a lot of place जैसा यहाँ पे दिया हुआ है M, so you can see over here there's an यहाँ पे नजर आ रहा है M और ये दिया हुआ है ratio. So how many number of carbon atoms? Or this is all you have to do. That's the number of carbon atoms would be 100 over 1.1. Calculator से भी ये कर ले. M plus 1 कौन सी है? That's 0.2. And what's the M height? That's 5.9. So what do we get?
3.0.
तो उसको राउंड कर लेना 3 कार्बन आटम्स. ठीक है, वो हर क्वेश्चन में ना, मतलब ये बाकी क्वेश्चन तो खैर A2 का है. आप लोगों के जो स्टार्ट वाला पार्ट है ना, अगेन इट्स they've given you the m plus 1. वही नहीं है ये. इसका दिखा दो कि m plus 1 over m 5.1 into 100 over 1.1. इसका क्या आ रहा है? Is this 7 or what?
3.9.
अच्छा चलो ठीक है, 4 कार्बन आटम्स. ठीक है, तो बस ये, इसमें और कुछ भी नहीं है. ठीक है, और एक वो है कि सो इज दिस क्लियर कि और कुछ भी नहीं है. वन इज दिस वन, कि इसको याद रखना है. नंबर ऑफ कार्बन आटम्स. फिर ये वाला टेंटेटिवली याद रख लो, क्योंकि अब मेरा नहीं ख्याल इसकी ना कोई जरूरत है. इसके ऊपर मैं लिख भी देता हूँ. पहले थी ऑब्वियसली, पिछले साल तक तो थी, पिछले एग्जाम तक भी थी. इसके ऊपर मैं लिख लेता हूँ कि टेंटेटिवली वैसे याद रख लो. ऑन द सेफ, जस्ट टू बी ऑन द सेफ साइड. नहीं करना तो मेरे ख्याल से तब भी छोड़ सकते हो. बस अभी तक हमने कोई पेपर देखा नहीं है, तो इसलिए. और इसमें भी ना ये 2 BRs वाला जो है ना, ये जो 2 BRs वाला है ना, m plus 4, इसके ऊपर भी मैं मार्क कर देता हूँ. m plus 4 वाला जो पार्ट है ना, अच्छा शायद अब ये भी नहीं है. और एक वो है, अच्छा बाकी एक था कि रिलेटिव वो निकालना. इसमें भी ये मैं शेयर भी कर दूंगा. और इसमें ना अच्छा इसके अंदर A2 का भी हुआ है एक से, वो भी मैं रिमूव कर दूं. ठीक है, इसके ऊपर भी लिख लेते हैं. जस्ट टेंटेटिवली रिमेम्बर दिस. अच्छा इसके नीचे ना, हाँ फ्रैगमेंटेशन के ऊपर. ऑल्दो आई थिंक फ्रैगमेंटेशन जो है ना, that is also not anymore in the syllabus. MS नहीं उन्हें दिया हुआ है. Suggest the entity of molecules form as. नहीं ठीक है, fragmentation है. So fragmentation का थोड़ा सा I'll just give you an idea. अच्छा now here's my molecule, right? It's CH3C. So fragmentation का just I'll give you a little bit of an idea. Okay, well, this is CH3 and the next one is C with CCLs, right? That's your molecule. That's your molecular ion. Okay, this one over here. Achha, now remember this, when fragments are formed, the fragment is a tinier piece of the bigger molecule. The molecule gets smashed by electrons and it breaks up into smaller pieces. So the smaller piece could be any piece. ठीक है, हमने पहले भी डिस्कस किया था कि you could have this piece, a CCl2 piece, which so maybe I'll add this. ठीक है, that could be my fragment. So any small piece of the bigger molecule, that's a fragment. ठीक है, is that clear? ये बात clear है? Yes or no? Can you hear me?
Yes.
So now what can happen is, by looking at the smaller pieces, you can get an idea of what the molecule looks like. Okay, if you can figure out, like in this case, okay, ignore this. ये नीचे वाला मैं हटा देता हूँ, कट कर देता हूँ, ठीक है. Let's say there's a mass spectrum that's given and the mass spectrum looks like this. Okay, you have a molecular ion, that's the big piece, the bigger molecule. जो आखिरी heaviest होता है ना, that's the molecular ion, ठीक है. Usually that's the molecular ion. और ये उसके छोटे छोटे pieces हैं. तो मुझे बताओ, guess करके बताओ कि जो सबसे छोटा piece है, that's probably an atom, right? मतलब इसका जो सबसे छोटा piece होगा, that would probably be a carbon atom or a Cl atom, right? तो इसका सबसे छोटा piece जो है 14 है. So what do you think 14 is? I mean, what element is 14?
Carbon.
नहीं, 14 क्या होता है? 14 is nitrogen. 16 पे क्या होता है? What is? So there's another thing that's a smaller piece that's getting detected, and that is इसका इससे ताल्लुक नहीं है, ये ऊपर वाले से ताल्लुक नहीं है, ठीक है? But just remember, इसका इस ऊपर वाले से कोई ताल्लुक नहीं है, ठीक है? It's a completely different question. So 14 is nitrogen, right? Is that clear?
Yes.
अच्छा, फिर you're detecting something at 16 as well. So that would probably be an oxygen, right? I mean, this would be probably a nitrogen ion. This would probably be an oxygen ion. Is that clear? अच्छा, then you move to the bigger piece. So जो bigger piece होता है ना, that's probably a combination of the smaller pieces. 28 क्या होगा? या मैं पहले इसके साथ कर लेता हूँ.
N2.
ठीक है, 28 would probably be N2, right? 30 क्या होगा? 30 भी नहीं का कोई combination होगा. That would be 14 plus 16, that's NO, right? Is that clear? फिर 44 is the biggest piece. कि 44 होगा जो, तो वो इन सारों, मतलब it's you can guess by looking at the smaller pieces, you can guess what 44 might be. ये जो छोटे छोटे pieces है ना, ये सारे के सारे इसी में से बने हुए हैं. तो आपको हंच लगाना पड़ेगा, what is 44? So 44 would probably be N2O. Is that clear? but ये idea clear है? Yes or no? Is this clear?
Yes.
और इस वाले का भी कर लेते हैं कि अगर मैं इसकी ना mass spectrum करूँ ना, कि the mass spectrum would kind of look like this. कि probably कुछ ना 12 पे detect हो रहा होगा. I mean, there would be some detection at the mass 12, right? फिर हो सकता है कि 15 पे कुछ detect हो रहा होगा. अच्छा, फिर there might be something getting detected at let's say 35, and also let's say उसका 35 वाला ही isotope है. तो ये जो छोटे छोटे pieces detect हो रहे हैं, अब 12 वाला आपको guess कर सकते हो 12 वाला क्या होगा? That, I mean, if you 12 would be carbon, right? That is what 12 would be. 15 पे जो fragment detect हो रहा होगा वो probably कौन सा होगा? CH3 का होगा. 35 पे क्या detect हो रहा? That must be chlorine. तो आपको ना, if you look at the smaller pieces, आपको थोड़ी थोड़ी information मिलना शुरू हो जाएगी molecule के बारे में. Like you would know कि इसके ऊपर लिख भी देते हैं कि भाई this would be a carbon. You would get some hint that there might be a CH3. You wouldn't be 100% sure, but you would, I mean, that would be an intelligent guess. 35 के ऊपर अगर कुछ detect हो रहा होगा, so you will guess that it might be a Cl. ठीक है. इसी तरह अगर कोई piece इस तरह detect हो रहा होगा 84 पे, इसको अगर मैं extend करूं, और ये time भी हो गया. अच्छा, let's say 84 पे detect हो रहा है, तो आप ये smaller pieces से ना guess करोगे कि भाई एक कार्बन और 2 Cls को अगर इकट्ठा करो ना, that 1 carbon and 2 Cls, that would probably be 84. तो आपको उसके ना छोटे छोटे स्ट्रक्चर्स के बारे में पता लगना शुरू हो जाएगा, भाई इसमें CCl2 भी है. ठीक है. Is that idea clear? that the
Yes.
fragments would help you in identifying what the bigger structure might look like. तो इसमें देख लेना, ये एक और क्वेश्चन किया हुआ था, ये क्वेश्चन, दिस वाज एक्चुअली अ क्वेश्चन, जस्ट गिव मी 2 minutes, ठीक है. एक क्वेश्चन था, उन्होंने कहा था कि there's a molecule, there's a big molecule, and you had to figure out the structure of the molecule. They told you that it had silicon, which had a mass of 28, Cl, which had a mass of 35, and oxygen, which had a mass of 16. And when they did the mass spectrum, the bigger molecular ion was 396, and there were lots of tiny fragments, 133, 149, 247, and 263. So first thing is, तो आपने ना ये figure out करना था what was this bigger structure like. The way you did this was कि 133 पे आपने पहले combinations निकाली, what could make 133. So you would figure out that 3 Cls and 1 Si would make up 133. So that would be your fragment, 133. 149 has a difference of 16. So that means there must be an oxygen added to the same fragment, right? Pair 149 and 247 is a bigger fragment, which is made up of these smaller fragments. So 98 का difference आ रहा है. 98 you figure out कि SiCl2 होगा. So it must be this thing with an SiCl2 attached to it. So it must be this fragment. उसमें फिर there was another difference of 16 and 263 आ रहा था. There must be an oxygen added to it. And then 396 was the big one. So there's another 133 being added. So there must be an SiCl3 at the end. So you were able to figure out this bigger 396 by looking at the tinier fragments. Is the idea clear?
Yes.
चलो बस इसमें जाते मैं ये कर लूँ, कल भी हम एक क्लास ले लेंगे ताकि वो रिएक्शन काइनेटिक्स में कुछ है तो नहीं, वो वैसे कवर कर ले, इसे भी कर ले. H NMR remember is A2, ये इसके अंदर है, that is A2. एक और छोटी सी जो चीज है ना, that is यहाँ पे इंफ्रारेड है, वो भी फिर हम कल करते हैं, ठीक है. वो एक्चुअली बस इतनी ही है जितनी यहाँ पे नजर आ रही है, वो फिर कल करते हैं, ठीक है. इसका मैं लिंक शेयर कर देता हूँ आपके साथ. ओके देन, अल्लाह हाफिज.
अल्लाह हाफिज सर.